Alright, so in this video we're going to be expanding on what we talked about as far as just one variable inequalities and two variable inequalities, and to how we could use these to solve systems of inequalities, meaning two or more inequalities in the same problem. So just to review the rules we've already gone over, and I'm not going to do too much talking through here, but just know the difference between a solid and dashed line and shading, where you shade above, where you shade below. So if you need to rewrite these tricks down, please do. And remember, down bottom, you have to flip the inequality sign if you're multiplying or dividing by a negative somewhere along the lines in solving your problem. And on these, my hint to you, and I'm going to show you the process I use, and you can use it as well, it's just easier if you graph one line first and then shade that line, then go jump to your other equation, graph it, and shade. If you try to graph both lines first before shading, you're going to get confused as to which one you're shading when you go back to shade. So graph one first, shade that one, then go graph the other line and shade it. So let's get started. To begin with, you need to know what solutions we're going to have. So back when we had systems of equations without the inequality signs, you had two lines that were crossing, and we said that one point where they cross is the solution. We're not going to get just 1 point for these because we're ended up shading on these. So we're going to have two lines maybe that cross, but we're going to have shading on this side, shading on that side. So we're looking for a solution region where the shades overlap, where one shading overlaps the other. And it's called a solution region because there's infinitely many solutions in there. Any point I can pull out of that region is a solution. So let's see what we're talking about. So one thing I'm going to do to help you out while we're learning this is color code some things. So this first equation I'm going to deal with is blue. This one down here will be red. So anything I write in blue goes with the first one. So let's just talk about, we got a graph, so we have to know how we're going to graph it. So we need our M and our B. So M here is -1. B is -2, just pulling off our slope and y-intercept. And then we need to go figure out if we need a dashed or a solid line. Well, I've covered it up kind of, but there's a less than or equal to sign right here. So if it's less than or equal to, we know it's going to be a solid line. And we know we need to figure out if we're going to shade above or below here. Well, it says less than, so remember less than, think below, so we're going to shade below. So let's go graph this one first. Remember, we're going to do everything with one equation first, or one inequality, sorry, before we go hit the next one. So we're not confusing ourselves. So we're going to go down to -2 and put a point. We're going to use our slope then to go down 1 over 1, down 1 over 1, and so on. Alright, and we said it was a solid line, so I'm going to draw us a solid line. It's not going to be perfect, but you can get the idea. And it said shade below, so remember, if you can draw your arrows going down, that's where below is, so we're going to shade all down here. So that takes care of one inequality. Now we have to go do the other one. Alright, so this next line has a slope of -5 and a y-intercept of 2. It's greater than or equal to, so that tells us we're going to have a solid line, and since it's equal to, that is y. And then if we want to know where we're shading, since it's greater than, that's going to mean above. So let's go put all that on a graph. So you want to go up to +2, put a point, go down 5 over 1. So they do cross, but remember that point is not the one solution. So this one's going to be a solid line. And it said shade above, so we're going to shade over here. So if you look down here in the very bottom of this graph, the blue and the red overlap in this little bitty area right here. That's going to be our solution region. So all of this, I'm just going to make darker. This piece is the solution region, which means any point I pull off in here, any point is a valid solution. Now, over here in the red area, over here to the right, this one, any point I pull off would be a valid solution for the red equation, and same thing over here with just the blue. If it's just the blue area, any point I pull out of this area would be just a solution to the blue equation, but I want the area that's a solution to both, which is where I highlighted in green. Alright, this next one, if you remember Hoy-Vux, and again we'll color code some, Hoy-Vux tells me that this x is less than or equal to -3 is going to be a vertical line at -3. So I'm going to put us a vertical line. We'll try to make it dark so you can see it. Vertical line at -3. And we need a solid line. That's why I drew it solid. And we need to shade less than, which in this case is going to be to the left instead of below. So less than would be anything to the left of this line. Alright, this other one, the slope is 5/3. The y-intercept is 2. It's going to be a dashed line this time because there's no equal sign underneath the inequality. And we're going to shade below because it's less than. So we're going to go up to +2, put a point, go up 5/3. And again, they cross, but that is not our solution. Alright, so there's our dashed line. We said we're going to shade below. So everything below this line is red. And then again, for these systems, you're looking for where the colors overlap or where your shading overlaps, which in this case, again, is going to be this little baby triangle down here. And just know it goes on and on forever down here because these lines go on and on forever. Alright, this one you'd have to rearrange first in order to get there. And let me see how many more we got. Okay, so we can do this one real quick before time runs out. So we need to rearrange this first one. So 3x plus 2y greater than or equal to -2. I'm going to subtract 3x. 2y is greater than or equal to -3x minus 2 divided by 2. And if you're not knowing how I'm doing this, go back and watch the video on how to solve equations. Alright, so there's one equation. And then the other one I need to rearrange for is x plus 2y is less than or equal to 2. So I'm going to subtract the x. 2y is greater than or equal to -x plus 2. Divide both sides by 2. So y is less than or equal to -1/2 x plus 1. Alright, so let's do the first one in blue again. So I'm going to just talk through this one in order to save some space because I'm running out. So our y-intercept's -1. It says go down 3/2. I'm just going to put a few points. Solid line, just to give you an idea of what we're talking about. Oh, sorry, missed that point altogether. Alright, and then it says greater than or equal to, so that means shade above. So we're going to shade everything above here. Alright, and then we're going to do this one down here in red. So we need to go up to 1, put a point, go down 1/2. And it's also going to be a solid line. And it's less than or equal to, so I want everything underneath or less than the red line. So again, you're looking for where they overlap, which is this little baby triangle area right here. Alright, so here's your practice. Pause the video and go sketch these out. If you have graph paper, that would probably do better. If not, just try to be as accurate as you can. And then when you're done, unpause the video and come back and check your answers. Alright, here's your answers. Just follow kind of through what we were doing. I've done them the same way. Written out everything you need. So solution regions in green. If yours does not look like it's in the same location as mine, make sure you go back and try to figure out what went wrong. Alright, make sure you're doing your horizontal vertical lines correctly. And your dashed and solids. Alright, there you go. So just to recap too, just like when we have regular systems, we can have two lines that don't ever cross, parallel lines, and it could say shade this one above and shade this one below. Well, if the shadings don't overlap, that's just kind of like what we had when we had this scenario where it's one solution and then we had the lines that never cross, which meant there was no solution. If the shadings don't ever cross, that's like two lines never crossing, so there is no solution for this one. So keep that in mind, that's an option. And until next time, keep practicing.